Hi there, and welcome to Ian's Engage channel. I'm Ian. In a previous instalment, I showed how I'd utilised some baked bean tins to install the first section of the tricky bit in the train room. I've paused work on the first section for the time being, until I figure out exactly how I'm going to best reconfigure the DCC bus. So, in this video, I'm going to show how I've started work on the second section of the tricky bit. I figured getting the complicated sections out of the way first was my best option, so that meant dealing with any sections with point work. This meant tackling the section that brought both loops back through the scenic breakboard into the scenic section of Shelfington. I'd already pinned the track plan to the baseboard, so the next thing to do was to transfer the track plan to the Cork below. I did this using my usual method of poking holes through the track plan into the Cork with a bradawl, then making the holes more visible using a Posca paint pen. Once I'd perforated the cork with a multitude of holes, I played join the dots. Eventually, after joining many dots together, I'd transfer the track plan to the baseboard. Now that I knew where the points needed to be laid, I set about temporarily securing them to the foam baseboard using staples. The Type 90 staples I now use to pin the track to the foam did the job so much better than standard track pins, and I thoroughly recommend them if you're using an XPS foam base. Once the points were in position, it allowed me to see where their tie bars were located, which in turn allowed me to use the paint pen again to mark where the point rodding would go. As soon as the point rodding positions were marked, I could remove the staples and release the points. Removing the points allowed me to mark the point rodding channels more accurately. Once I had the more accurate marks, I could cut out the channels. I used a combination of my utility knife and a tool designed for modelling with clay, which was perfect for the job. I can't take credit for using the clay modelling tool, as it was suggested to me by Stephen at Elvenholme, and it worked a treat, so thanks Stephen. The next step was to install servo enclosure boxes to align with the point rodding channels. But first I needed to make some new ones. I actually had lots of boxes already made, but these were to my old design, and they were likely to trap the servo motor should it fail, so I thought it would be better to make some to the new design. The parts were cut out of 2mm Greyboard using my cricket machine, and I'd learned that filing the edges of each part made the boxes easier to construct. To glue the parts together, I used Loctite fast-acting PVA glue, which was quite grippy, so it was good for connecting multiple parts together quickly. Before the glue dried, I made sure that the boxes were square using a scale model scenery 90-degree assembly jig. The next step was to prepare a couple of servo motors that would sit inside the enclosure boxes. This is where I had a bit of a senior moment, as I couldn't find the servo horns for the motors. I looked literally everywhere. Everywhere, that is, except the workbench right in front of me, where they were sitting about a foot away from where I'd been working. Anyway, the first job was to check that the servo motors were working correctly by connecting them to my servo tester. I was glad I'd tested, as one of the motors had a problem. This was the first time I'd encountered a problem with a servo motor out of a couple of dozen that I'd tested. Once I'd found and tested a replacement successfully, I needed to trim the screw lugs off each of the servo motors so that they were of the correct size to fit into the enclosure boxes. I'd found a little vise in one of my old toolboxes that had a rubber suction cup to secure it to a surface. To be honest, it had proved to be pretty useless in the past and wouldn't stick to my cutting mat or the wooden tabletop. However, it did stick rather nicely to the smooth base of my upturned plastic tray. So I clamped a servo motor between its jaws and then used my Dremel with a cut-off disc to trim the screw lugs. It was definitely a lot safer having the servo motor held by the vise than it was holding it between my fingers. After trying a test fit in one of the enclosure boxes, the servo motor was still a fraction too wide. So I ended up having to use a file on the edges of the motor to make it a smooth fit. After a small amount of remedial filing, both servo motors fitted nicely within their enclosure boxes. The next step was to install the enclosure boxes into the baseboard. I used one of the boxes to measure where they would sit within the baseboard. I then used a combination of a chisel and utility knife to cut out a notch that they would fit into. Once I was happy with the notch, I glued each of the enclosure boxes into position. I used bits of card to pack out the edges of the enclosure box where I'd cut a notch a little too wide. I then popped a servo motor that I'd tested into each of the boxes. Once the servo motors had been positioned, the point rodding and the brass tubing that it ran inside could be cut to size. However, I needed to refit the points in order to get the measurements right. I did this making sure that I lined the point tie bars up with the point rodding channels I'd cut earlier. Once that was done, I could measure the length of the brass tubing, marking where to cut it with a Sharpie pen. I then used the cut-off disc again in my Dremel to cut the tubing. Next, I bent some of the point rodding at one end. I then inserted it into the brass tubing and put a piece of blue tack on the end, so the tubing wouldn't fall off. I then hooked the bent end of the rodding through the hole in the point tie bar. This then allowed me to mark where to cut and bend the other end of the point rodding. I cut the point rodding to size using a pair of snips, and then bent the end using a pair of long nose pliers. Next, I could snip the long end of the point rodding at the tie bar. I could now test the temporary installation of the points and servo motors using my servo tester. Okay, so that's about it for this update. As usual, I haven't been able to do as much as I'd have liked. So, what's left to do? Well, firstly, the points need to be installed properly, and this involves replacing their frog wire with something more robust, and gluing them down. Then, the remaining pieces of track need to be cut to size, and laid temporarily. I can then mark where the dropper wires will go on both the track and the baseboard. Holes can then be drilled into the baseboard, and this can be used as a template to drill holes into the plywood baseboard in the train room. I can then prepare the other sections of track for the dropper wires to be added. Once prepared, the dropper wires can be soldered to the bottom of the track. The track can then be refitted to the baseboard and glued down. The section can then be taken to the train room and installed in place, in readiness for connecting up to the DCC bus. I've got my fingers crossed that all that will get done by the end of November. But let me know if I've missed anything out. Alternatively, if you've got any hints, tips, useful tools or techniques to pass on to a fellow N-Gage modeller, or if you simply want to say hello, then please do so in the comments section. Anything and everything you've got to say will be greatly appreciated. In the meantime, thanks ever so much for watching. Hopefully I'll have another update on my progress soon. Bye.